This is a massive bro moment.
So
And then
do we like mute? Oh my god, that's so
you
cool.
don't have to mute. Look, I already got you set up. This is
He's
AP
prepared.
Calculus
Oh,
BC,
you forgot,
Chapter 1.
you forgot continuity.
What?
You forgot to write continuity in
Hold up.
short limits.
It's fine, it's fine.
I don't
What
even know
is
what you
this?
mean. 1.1 to 1. Oh yeah, limits and continuity.
How do you spell
See, and I have a
continuity?
little limit here.
You're an AP
Okay.
Lang.
Watch.
I don't know how to spell this
Alright, I'm
word.
Okay, don't worry.
Continue, itty. Continue.
Oh,
Itty.
okay, go
Without
ahead,
the
go ahead,
E.
go ahead.
Okay.
Yeah.
With Jacob Jordan and Tom Yao.
Oh man,
This is the first time we're bringing on Tom Yao to the show, so hopefully this goes well. So, there are two sections on the Google Classroom review. There's a no calculator MCQ and FRQ, and a calculator MCQ and FRQ. I think the units are just kind of dispersed within them, but I think we can just go over these. So question
We should
one.
first ask, we're just going 1 through 4. Yeah, okay.
Yeah, do you want to? I thought we would just do
I
it in
don't-
order.
yeah.
Sampling.
If there's anyone like specific question, if anyone has like one
Yeah.
that's really hard. Yeah.
If anyone
Yeah.
wants to throw a question onto the whiteboard, you can send it to me or Tom. I know Aaron, you said you might have some stuff to send, so just whatever works.
Aaron, when are you coming back?
Tomorrow.
Tomorrow? Let's go.
So let's get started with number 1. So here we have a piecewise. The function is this when x is not equal to 3, and 6 when x equals 3. When you get something like this, you should probably start by factoring. So in here we know it's going to be x plus 3, x minus 3 over x minus 3. So you know that there's a removable discontinuity when you can factor and then take it out of the top and the bottom. So here 3 would be a removable discontinuity. If the x plus 3 was on the bottom, then negative 3 would be a vertical asymptote. But because it's on the top, it doesn't matter. It's not discontinuity in this case. So here, we'll just resolve each one by one. So limit as x approaches 3 of f of x does not exist. So what are you guys thinking for this question? What do you think?
False.
False. So we can plug in 3 here. We'll just take out x minus 3 over x minus 3. Plug in 3 here. We get 6, which is the same as x equals 3. A limit exists if, as you approach it from either side, you reach a number. And I think even if this was a different number, even if it was like 5 or 1 or whatever, that the limit would still exist because it still approaches 6 from either side.
Yeah.
So this is false. See, which of the following is true? So it's a little bit of a tricksy question. F is continuous at x equals 3. So what do you guys think of this one?
True.
Yeah, I agree. F is continuous because this is a removable discontinuity, and we see it's defined at this point.
Yep.
So I would say that's true. X equals 3 is a vertical asymptote. I'll answer this one because it's pretty simple. No, it's not. It's a removable discontinuity.
Let's go.
So this one, I believe, is 2 only. So that's a simpler question. Here, Tom, you want to go over the next one?
And then we immediately move on to a more difficult question.
Yeah, well, this one isn't too bad.
It's not difficult, but like it's a different type. So this one, if you want work for it, like you can also use the T'Potau rule to take the derivative of the numerator and the top. But since we didn't technically learn it, we're not going to be using that for the test. So to do these type of problems with trigonometric functions like this, you're gonna have to, you're gonna have to create bounds like this and use squeeze theorem.
Yeah. So,
Can you stop interrupting every 5 seconds?
No.
Okay.
So this is-
you always
this
start
is
out
new,
with
by
like
the way.
a trig function and its bounds, the lower one and the higher one. And you want to emulate this original f of x function right here. So we're going to do that by dividing the whole thing by x. And then we're going to take the limit of this entire expression, which will take the limit of each term. Now I'm going to simplify a little bit since I don't have too much space. But -1 over infinity is going to be 0. And I'll write limit.
Yeah, it's lagging a bit on my screen, but
Wait, I have a
you see what I
question.
mean?
Yes.
Wait, is this one of the ones that we learned, like how cosine x over whatever, or 1 plus cosine?
No, that's I'm
No.
gonna write that here. That's limit as x approaches 0.
Yeah, as
It's
x
very
approaches
close.
0, it's 1.
All right, thank you.
This is something you just have to know. You can also, well, just know that. There's a proof for it that's 9 minutes long and takes too much effort to learn.
Yeah, that's just a memorized one.
Oh, look, we have 0 on both sides, and the squeeze theorem tells us that if both sides are like the same number, then this value also has to be 0, which is also kind of common sense.
Yeah, so we know sine x is between 1 and -1 because those are the normal bounds. And actually, if you're doing this problem intuitively, without proving it with the squeeze theorem, the squeeze theorem is nice to show your work easily, but if you forget it, you can solve this one intuitively because you know sine of x is never going to be greater than 1 or less than -1 while x is unbounded.
Yeah, so this one will just keep increasing.
You can just provide your reasoning for that, and I think that would work as well. But the squeeze theorem is just an easy way.
As you see, when we come to the FRQ, it asks you specifically to do this with a squeeze theorem. And I'm pretty confident that something like that could show up.
What did you just do?
Well,
I'm not. What is the 1 over x?
Okay.
I divided the whole equation by x to emulate this original function, sine of x. My original function was just the bounds, like sine of x is less than or equal to 1. Is that right? Yeah. And then -1 is less than or equal to sine of x, because these are the original bounds. And I took it, divided everything over x to make it look like this. And I took the limit of that expression. So this whole thing, I took the limit.
Yeah.
As x approaches infinity. And for 1 over infinity, it doesn't matter the sign, it's going to be 0 for both.
Okay.
Yeah.
Alright,
I'll do this.
Clear some space.
I'll do this next one. Yeah, you can clear it. So here's a type of problem where you can solve it by taking a reciprocal, by multiplying by a reciprocal. So for example, here we're going to want to multiply by root h plus 5 on both the numerator and the denominator. As you can see, if right now we plug in 25, we're going to get 0 in the denominator, so we need to manipulate the function. On the numerator, this will result in h minus 5, and in the denominator,
h minus 25.
we'll have h minus 25 times root of h plus 5. Now this is still going to be 0, so there's still work in what?
The numerator is h minus 25 because it's 5 times 5.
Oh yeah, you're right.
Just a little error. You're good.
Yeah, but in this case, it's a little error, but it actually makes a big difference in this because that makes it removable. So you would just remove this, make it 1 over root h plus 5. 25 root 25 is 5, so that's going to be 1/10.
I want to note, like I just realized this right now, you can also factor this bottom part into root h plus 5, root h minus 5, and then it will...
Well, you could do that. I mean, essentially you're doing a similar thing.
It's very similar. So there's multiple steps to approach these ones. The roots, mainly though, the main strategy is conjugate. Get conjugate in and find how to apply it as best as possible. It
Yeah.
may seem like it'll make it bigger, but something will probably cancel out. And if it doesn't, start plugging in numbers that are close to 25 is your go-to. But
Yeah.
this is also no calculator.
This is
so-
no calculator, so that will be difficult with the square root.
Yeah. It is the
entire test, no calculator?
the one
No,
strategy
there-
to like brute force everything. So
There
just like plug in
are-
something close.
So there is a no calculator and a calculator section.
Okay.
I don't
gotcha.
know how each side is weighted, but on the practice there have been this practice there's equal number of calculator and no calculator.
Okay.
It also has no calc for FRQs and calc for FRQs. So they separate those as well.
Yeah. So Tom, you wanna go over this next one?
Yes. So nothing is actually factorable here, which is really sad. Wait, Mike.
Wait, x minus 4, x minus 2.
Yeah, well, it doesn't. Nothing. I meant
You
nothing
can't
is
cancel
cancelable. Is what
Yeah.
I meant.
Yeah, I get it.
So, the easiest way to do it would be to plug in a number close to 4, like 3.9. So I'm gonna demonstrate. This is what I think is the easiest way to do it. I don't.
This is no Tom. This is no calc.
Yeah, do it by hand. That's what I'm
Well,
True.
My God.
is there another way to do this, Tom?
saying. I'm not entirely sure, but it actually isn't as bad as you think it is. All right. Wait. Why
So
don't I don't know why I
for-
wrote X.
I think
Three.
it low-key is.
This cannot possibly be the way that he wants us to do this.
Yeah, wait.
You can also
you
like
continue going, I'll see it.
yeah. This is how I did it. I don't know if there's another way to approach this.
I think there is. If
I
you
think
can,
there's
Can you
gotta
do you
This
can
is
factor
like-
the top into x
Wait,
plus.
wait. So you see that this has to be a vertical asymptote because you can't cancel out anything, so it's not going
Well,
to be
you want to know if
removable.
it's negative.
And
you
you
want to
know
know if it's
coming
negative or
from,
positive.
You know it's coming from the negative side. So if we see vertical asymptote, it looks like
This one's negative, positive, positive.
right?
So
we
this is
see
how
from
you
the
do it.
negative side, or actually it's going to be like
Looks like
this.
this. Yeah, you got it.
So you see it's going to approach infinity through this.
Oh, mine is better
Well,
because on Desmos it says that.
It's a
Wait, it does
calculator.
not approach it. Wait,
Does
Jacob,
it?
it doesn't.
it-
No, approach negative infinity.
How can you tell?
How do
'Cause
you
it's on
figure
the-
that out?
it's-
Yeah. How do you know this?
Okay, look at my substitution, right? I put 3.9, which is to the left of 4, right?
Oh, this is
I-
actually a good idea what Tom has done here. To
Yeah, when I
factor
plug
and
it
then
in-
substitute.
You can see that 3.9 minus 4 is going to be negative.
Yeah,
a negative times a
'cause you see it's
positive
gonna
is
be
going to be
negative.
negative.
So
And
this,
the whole thing will be negative.
so
So you
here,
have
this
to
is
plug
how
in
I'd
that.
actually do this. Now that we've gone over this, is that this shows you that it's going to be a vertical asymptote, so you can take out these, and then this shows you that it's going to be increasingly negative because you have a negative in the denominator. So then that would lead you to this, and then you can just solve this. This is a lot better than what I thought you were gonna do, which is just putting it in here.
Well,
It's
it
checking
is
it's
it is
3.9
putting it in,
squared.
but like
Well,
you don't have
after
to
it's
solve it
factored.
fully.
After it's factored.
Yeah. You don't want to square 3.9. That's a bit of work there.
Yeah. Alright.
That's what you need to do.
Are we
What?
good with all 4 of these?
If we're good with these, I say we should move on to the first multiple choice from no calculator because that was quite difficult. And then we can
Oh,
move on to the
with calculator?
No calculator.
This is
For-
your calculator.
You mean the
Right.
first free response?
Yeah. Oh, sorry.
It-
I
to
misspoke.
multiple choice. Yeah. Okay.
Jacob, should we? I have a multiple choice non-calc that it's a little bit difficult, but if you want to do the FRQ first, then
Okay.
No, go ahead. We can do yours first.
Yeah, wait,
Second.
send it to me. Here,
It's
Tom,
another-
because I'm recording. Do you want to send it to Tom and then you can copy
Well, you
it
can
on?
just tell me the number because I have the 1 through 10. Is it?
it's number 8. It's the one we spent like 15 minutes on. I think it'd be good for everyone else to know how to do
I
this.
mean, that's true. All right. Boom. Look how big and glorious it is. How do I delete all of this? Oh my god, everything's still here. Oh, it's a mess. Oh wait, I just got rid of it. Let's go.
What
Oh my
is going
God.
on?
Just cleaned up the whiteboard,
Dude,
and I
you,
was so
you
broke
sir,
part of the continuity.
well,
Hold on,
that's poetic, you know. The continuity,
the continuity. There we go.
the continuity is broken. You know, that basically works. Okay.
I spent too long on this question because I was being dumb.
I haven't done this question. Do you multiply by the conjugate? Oh, you can't, right?
Yeah, it's no.
Well, you can.
Well, you can, but it would
With
make it into a
reciprocal,
fraction.
it does work, I think. But now that I'm looking at it, there's also completing the square, right?
Yeah.
X squared minus 4x. Keep this in here.
Wait,
Plus
can you do that?
4
Is that the increasing? Oh, you put it outside of it.
minus 16. Yeah.
Yeah.
Then,
So this
will
would be x minus 2 squared. I mean x minus 2 minus x.
Eh.
Yeah, just.
Which
so,
is just
so
this.
This is an algebraic concept.
Do you add 4 on the outside? Or
Good.
wait,
Since this part
You
is
add 6.
the root,
You have to subtract
yeah.
16, and then it's like.
you just subtract
So
16.
this is gonna be x minus x.
Well, wouldn't you add the root of 4, or is it 4 squared?
Wouldn't you? Why would you do
Wouldn't
16?
it be 2?
It should be 2.
Who put 16 there? That was really weird of them. I don't know who did that. I don't know who's writing 16. I don't know who they think they are.
That's my bad.
Anyways.
Oh, this is intriguing.
No, but like problems like these are the ones that I look at and I'm like, this makes sense
Look,
now. But there's no
it's-
way I would think to do that on the test.
I
It's
just
negative
thought to do that
4.
right now.
Okay, yeah, I'll tell you the method that I
Can
solved it
we-
with originally.
Here, wait.
that-
I just want to try multiplying by the conjugate because I feel like that's what I
Yeah,
do on
yeah,
a test.
you should do
and
that.
I'll see how long it takes me. Because I feel
It
like
does work.
that method is a lot faster. I feel like I would do this if I was.
Yeah, upon looking at it at second glance, I like find new strategies to figure out how to do it. Here, I'll fix your.
The football game
Yeah.
starting soon.
This.
What's yours?
NFL. Bills versus
So this is going
Rams.
to be negative x squared plus x squared minus 4x over
The thing.
x squared minus 4x. Does this work?
Yeah. Well,
yeah.
I can't tell because you're writing it very messy. So they cancel it on top, and then you have the bottom part. Which, okay, the strategy is you're supposed to divide everything by x. So you'll have like, you just have to know that you can take these roots out and it will work out. But you have to do something like this over. This you can just do in your head. You don't have to actually write this out. Because, well, remember we stuck like with that one problem where you had to plug in a big number?
Wait. I know how I can figure it out from here. Because the x on the bottom is essentially all the x's are the same degree. So you can just.
I don't know why I wrote square.
You can just kind of take everything else out. Because
No,
everything is a
you
low
can't.
degree. Why can't you?
Because it's -2, isn't it? Am I stupid? The answer was 8. Yeah, the answer was -2. So my answer was
Wait, was
wrong,
it?
actually.
The answer was
Oh.
-4. What are you talking? Wait, what?
Yeah, I know. I wrote
Isn't it-
-4.
okay,
I'm pretty
wait,
sure
wait.
It's -2.
Why would
Is
it be
is it
-2?
negative
What?
2?
Because this part's squared, right? So when you take the square root of that part, there's gonna be the
Wait,
x.
Aaron, can you look this up in the textbook?
Wouldn't it just be 0 then?
Was this on the textbook? I don't know, but
Wait,
I'll look it up.
look up the answer to this. I don't know if you can find it. Could you? I'm sorry, I don't remember if an answer key was posted.
Oh, it's alright. I'll try my best to find it.
Yeah, this is a difficult question. If it is -2, I think it's going to be because you essentially add this x squared to the x because they're both essentially the same degree. And so then you get -4 over 2. I feel like I would not think to do this.
Yeah.
The levels.
I got tricked as well. Like I got -4 originally, and then I got -2 after shoving it into a cheat program that tells you all the answers.
So this is going to be a difficult question. if we get
Yeah,
this, on the
this
test,
is definitely one of the harder ones.
It's fine with AP curve though. Don't worry
It's-
about it.
Yeah, don't worry. AP curve is fire.
No,
Yeah,
AP
but-
curve is
Be a
great until
little
you say
bit-
that about every question.
That's not. You're being unreasonable, Ben Sadowski.
I do
You
Yeah,
think
say
that this
Some
is
of them are, like,
considerably
very-
harder than many of the other questions that we just did. And
Plug the answer or the thing into a limit calculator, and it says it gets -2.
Yeah, it's -2.
yeah,
Wait.
Actually,
So why-
do you mind if I share my screen? I can kind of show you.
Hold on,
how
let me see what I went
Oh, yeah,
wrong when I
sure, sure.
originally did it.
Or Aaron.
You did nothing wrong.
you
I
can
just
share
didn't
your
make it
screen,
fun.
but can you describe it because
Yeah, sure.
I'm not like able to switch.
All right.
I did it
so-
again. You did nothing wrong.
Steps on here, it's saying that first multiply by the conjugate. So
Okay.
you multiply that, and then you get -4x over square root of x squared minus 4x plus x.
Yeah.
Your stream is not
And-
loading.
Then what he did was they factored out. Trying to see what else he did.
Fix your stream, Mr. Hill.
I know it's bad, but
No, it's not just
Okay.
It's
bad.
just
I
not
actually-
bad. It can't load.
not
I,
loading.
I
It's
can't.
not-
I don't
it's
know why I'm
nothing.
getting
Tom,
-4.
Okay. I'll still try my best
Would
to
you say,
describe
Ben?
When you completed the square, is that supposed
Send
to
a
be negative
screenshot.
2 or +2 outside of
it.
the?
It should be -2 because it's x -2 when you complete the square,
Or what's the question? Wait, I'm
which
on,
which
am
should
I on my
make
own
it
screen?
-2.
I'm on my.
What? But you're adding 4. You're adding root 4, aren't you?
Well, you're adding root 4, so you have to subtract 2 from elsewhere in the function.
You add root 4 and then you
Oh,
minus root 4.
I'm thinking like there's an equal sign.
Yeah, yeah.
Yeah. When you do
Oh.
it within the function, it's like reverse.
You gotta,
Right.
you
So
gotta change
I feel like this should still, in theory.
I don't know why mine's not working.
Let's see. X
I'll
minus
share my
2
screen one more time.
I'm sharing my screen. I think mine's
minus
probably loaded.
X.
We're having
That's
a
probably better.
we're having a great debacle.
I know. But anyways, it's I'll try to describe it the best I can. So after taking multiplying it by the conjugate, they then took the limit. They used like a property, I don't remember the name, but they isolated the -4 out. So you have -4.
Yeah, they'll take out the
Times the
-4 and
limit.
like divide everything by x.
Actually, that's not. Yeah,
What?
kind of. Oh, they took out -4 and then it's multiplied by the limit of x over square root of x squared minus 4x plus x. And then they divided everything out by they divided the
screenshot.
numerator by x and the denominator by x squared.
Yeah, well, not the denominator by x squared. They denoted the inside the root by x squared and then outside the root by x.
This thing.
Yeah.
is-
And then
Yeah,
they
so
took the
this
limit
is what
of the square
Tom
root.
did. Yeah.
So it's gonna
Oh.
look like this, and you're gonna end up with this as your final answer, which reduces to. I know it's messy, but it reduces to -2.
What?
That is a
How do you-
scary question.
It is a
Yeah.
scary.
Better.
That's a
it's one
scary
minus
one.
0 in there.
Here, I'll try
Alright,
to take a screenshot.
We
Yeah.
hope not to see this one.
You can just take multiple
The
screenshots.
question brought up here. Thank you.
Doing emojis everywhere.
Time is
Okay.
running out. We
Let's-
shall move on.
Yeah, let's
Let's
move
continue.
on. My hope is to finish this before 1 hour, just to allow time for more questions, and also to make it so people
Pulling up
watching
the
the video
free
don't have to watch
response.
this so long.
Why are you sending emojis?
I got that free response.
What is going on?
Okay, so this is possibly the most difficult free response that I have seen in the entirety of limit section.
You got a
Tom
1
can
out of 4 on it?
attest. Hey, I got a 2 out of 4
You got a 4.
with
Okay.
respect on my first try.
Mhm.
So this is the most difficult limits FRQ I've done. So that's why I think it's the most important to go over. This first one is actually relatively simple. I still got it wrong, but you know we all have bad days. So sine of pi over 2 is 1.
1.
And
Yeah.
then x is pi over 2. We can move this
2 over
up
pi.
here because it's in the denominator of a denominator. So it's 2 over pi.
crap.
And then sine of 3 pi over 2 is -1. X is 3 pi over 2. We can move this up here. So it's -2 over 3 pi.
For
Yo,
anyone who doesn't-
do we get a
Oh,
calculator?
okay.
RQ?
Okay. For anyone who
And-
doesn't understand rate of change, you could have read what I was writing.
Negative. Here, I'll control Z. I'll take it back.
This is what Jacob's doing. If you guys are
We
not
can't see
understanding.
what Jacob's not
So
zooming
you,
in here.
yeah. Wait, I'll show later. So you subtract the initial from the final, and it's going to give you negative. But you can't do this yet because you have to multiply this by 3 on the numerator and the denominator. So negative 2 over 3 pi minus 6
Is it
over 3 pi.
Negative 8. Yeah. Okay.
That's going to be negative 8
Oh.
over 3 pi. But we then have to divide by pi because the distance between the first and the second is pi. So then when we divide by pi,
Yo,
get
did we get a
negative 8
cancel out here?
over
No.
3 pi squared.
Yeah.
What?
There's our cancel
You're
out. 'cause-
multiplying by the reciprocal of pi.
Why do you divide by pi?
Yeah.
Oh.
Well, I explained it, but Jacob very rudely removed
very
it.
elegantly.
It's right here. So the
this
top
is-
part he just did was this part where he substituted into the original function. The bottom part where he has the pi is when he did this.
Oh, okay. I see you.
Yeah.
I got it.
Also, isn't it negative? Did you start with 3 pi over 2 and then subtract pi, f of pi over 2?
What?
Did you?
It's the wrong way around.
Oh, he had f of pi over 2 subtract f of 3 pi over 2 when you did it? Because you should get
Yeah.
a negative pi for this one,
Yeah.
right?
I subtracted.
This should be
Yeah,
negative pi,
3.
and this should be positive, I believe.
What?
Thing's insane. This is evil.
Tom, it's
You know what?
3 pi over
It's-
2 minus pi over
It increases
0.
by pi. I
Yeah.
subtracted this by this, and this
It's
by
fine.
this.
It's fine. It's fine. It's
I
fine.
think you just have to sign.
No, yeah, he just did it the other. Yeah.
He just did it the other way. Okay, yeah, I
Jacob
got it.
is
I got
fine.
it.
Yeah, Jacob, yeah.
All right. What is limit? Tom, take it away. Wait, can I make
Remember
my
that thing we
eraser
had to
and-
memorize? So we're just gonna write limit of x of this,
You should do the same thing. No, you can't do the same.
and then you're like, "Well, it's 1." That's crazy.
It
You
says
get-
show work, or you're gonna like die.
This is the one you have to memorize. Show work. You want me to do the 9-minute proof on Academy?
It literally
do.
says show work, right?
You
Show all
cannot.
your work.
You cannot do that. Okay, I'll show work.
You
If
don't
you wanna
have to.
accept
No,
it.
no. We're
Here,
good.
just pan the
You
camera.
don't
away
have
while
to
we check
show.
over.
You don't have to show all of your work if you just know it.
Okay.
The limit of 0 sine of x.
So one of this
is 1.
require. This is actually a question that goes probably if she only requires
Alright,
stuff with
Tom,
limits
Tom, you don't
beyond
need to do it.
what we will do. So I don't think we will get a question like this on our
Well,
test.
if you do get
And
it,
if we
just know it's
do,
1.
It's probably
9
not going
minutes.
to ask you to show your work.
Wait, what's the
because to show
cosine one
your work,
again?
you don't prove it through.
It's like 1 minus cosine over x is 0 or something. I don't remember. This is off the top of my head. This could definitely be wrong.
This is probably wrong.
Jacob, do you remember it?
I don't.
Okay.
Sorry.
No, because sine is not the same thing as 1 minus cos x. Sine squared.
That's
is
why
the
it
same thing
equals
as 1
0,
minus
Yeah,
not
that's
cos
why it
squared.
equals 0 and not 1.
That's why it
Oh,
equals
okay.
0.
Okay.
Foraging forward is the line x equals 0 vertical asymptote of f. Justify your answer using limit. Well, we just see that limit of x as x approaches 0 of f of x equals 1. If there's an approachable limit that exists, there's not a vertical
No.
asymptote, because a vertical asymptote means that the limit there does not exist.
Or it's infinity or something. Yeah. It's
Yeah,
not. It's not defined.
It's not a finite value.
Yeah.
Yeah.
Use the Tom theorem to show the line y equals 0.
So
No, because-
we already learned. Well, I
Eh.
explained because we don't have to. Yeah.
What's that? Squeeze
Use the
theorem. This
squeeze
is the
theorem.
same thing I did before. To reinforce into your head why it works, I'm not going to. I'm just going to rewrite it again.
Yeah, to x.
Wow, I got it backwards. I'm so good.
Tom.
Shut up, shut up,
That's
shut up, shut up. 1, -1. Eh.
I'm making all these noises, man.
So yeah, we've actually seen this one already. So
Alright. Does that clarify?
Wait, but it's
And then
over
because it's
zero. If both of them are
yeah,
under.
so it's a horizontal asymptote.
Oh.
yeah,
Oh,
because
it's
to
zero.
find a
Is it zero?
horizontal
Wait,
to
it's
find
zero?
horizontal
Zero, isn't it?
asymptotes, you have to find the limit of the function at positive and negative infinity.
Wait, Tom, I'm confused in this because how is -1 over 0 equal to 0?
-1 over.
No,
well,
because
I'm,
infinity.
I'm
It's
substituting
over
infinity.
infinity.
Because you have to find it.
Okay, well, I didn't
Oh,
realize you
okay.
actually needed me to write out the limit part, so
Yeah.
here you go.
Well, yeah, that's very
Limit
helpful
scribble.
by you.
You substitute 0 in. You can also put in negative infinity, but
And
you
then
see,
what does
it
that?
doesn't
What does
matter.
that do? What does
Yeah,
that
in
prove?
some cases it will ask you for horizontal asymptotes, and there will be two, because you'll have one at positive and negative infinity.
Wait.
All right, do you want
There
to
will
bring
be
in?
more. There can be more
Um,
problems on this, by the way. What?
What is that? What does that 0, 0 show for D? What does that
Well,
show?
this is 0.
The
If
squeeze
it's
Yeah.
in between
If
zero,
it's
if it's
zero.
in between,
Yeah, I know. But does that show
So,
like?
yeah,
Well, that
because
that tells you that the limit of x approaches this of sine of x over x equals 0, right? Because I just
Mhm.
squeezed. I
Yeah.
put in my grapefruit and I squeezed and I got this.
But then it show the like y equals 0 is a horizontal.
yeah, when
asymptote.
you find the limit of a function as x approaches infinity or negative infinity, that is a horizontal asymptote.
Meaning it approaches 0 as x approaches infinity, which is like the definition of a horizontal asymptote.
All right, let's move on to the multiple choice questions with calculator. So everyone should get out their calculator.
Oh.
I
no,
lost my calculator 5 minutes before.
So we're skipping FRQ 2 because that would, it's when you did in class.
FRQ2 is easier. So we basically.
I'll put it up, but we're not gonna do it. Stick it up for anyone who wants.
I lost my
curious.
pencil.
Bruh.
Alright, if this work will be in the video again, so I'm gonna.
What the frick?
If anyone
Oh,
wants this one, it's
is that?
here.
This is the next FRQ. Even
Yeah, if you want to do it, I just put it in the
Yeah.
corner.
I'll zoom in real quick so you can take a screenshot if you want.
Can I use a TI-73 for this test?
No, don't use a TI-73. I don't even know how far that goes.
That's all I
Okay.
have.
Your calculator.
Okay,
That's all I have.
let's get some multiple choice on here.
I just want to say, calculator section, there's like it's like a lot of conceptual, and not a lot of plugging in limits.
I do feel like the calculator section tends to be easier though, even if it is conceptual stuff.
Yeah.
I feel like some of the conceptual stuff is easier.
Okay, I wanna up. You wanna just put like 1 through 4?
Sure.
Okay.
And then we can do the free response for that, and then see if anyone has any more questions.
Just in case people forgot what bumps do.
Ooh, that's a good
Little
one.
bump.
Yeah, so like the graph of f has a tangent line at every x in this interval, except for x equals. So this one, it's going to be 1. You see there's so many different tangent lines because of the bump that you could draw. Wait, let me dash. Like you
This
could
one you
have a
have
tangent
to
line like this,
understand conceptually.
a tangent line like this, tangent line like this. So when there are many tangent lines, that means there are no tangent lines.
Because there's too many.
What?
Well, there's like an infinite amount you can draw.
So what's
like,
the answer?
Oh,
there's no derivative at that point.
It's except x.
Oh, except x equals 1, because that's
yeah,
the
so
bump.
this doesn't have a true tangent.
Oh,
There are
it's like a
many
straight
lines.
corner.
Dude, okay, alright.
Alright, bring in 1 through 4.
All right.
Oh,
What are the ones above you, Jacob?
gotta have a
They're
thing.
the
This
FRQs
is the
we just-
FRQ we just went
yeah.
over. This is another FRQ if you
Eh,
want me
Okay.
to.
Is this calculator section?
Yes, this is the calculator section. Yeah,
Well, I don't have mine, so
I have mine. So using the
Got it.
table,
I have
yeah, using the
73.
table of values of f of x, the average rate of change on the ff on the interval -2, 4. So this interval is. This is gonna be one of the easier questions that you get on the whole thing.
What?
You essentially
this not here?
divide. It's just essentially a slope calculation.
Or
Like
is it
15
just
minus 1 over 6. So yeah, that's
What is that?
That's so
that's
easy.
7/3.
7/3? Yeah.
So you see what I mean about the calculator section being a little bit easier?
That's
I
conceptual.
have one
man.
problem.
yeah.
That's one problem.
Mm-hmm.
Well,
Wow,
that's a
conceptual.
problem you'll be happy to see on the test.
You're right,
I'll
you're
tell
right.
you that much. So
That's
this
true.
gives us the squeeze theorem. And it's asking us to evaluate some things with the squeeze theorem. So we know that a function doesn't have to be the same value as the function approaches at that value, right? So it's not true that it must be true that f of 2, f at 2 equals 5. And g of x is less than or equal to 2 for all x is greater than or equal to 2. Well, we can't, this essentially we're given nothing to assume what these functions look like, except that essentially by the transitive property f of x is always going to be less than or equal to g of x. So they could both be they could both be increasing after x equals 2, and g of x would not be less than or equal to 6. So we know
Genius.
this is also wrong. The limit
Genius play.
of h of x as x approaches 2. Oh, you were erasing the answer. I was like, what is going on?
Classic squeeze.
This is a squeeze, and yeah. I believe this one is true. It's just an expression of the
just
squeeze
substitute. You can just substitute those parts in, and have the limit there.
Yeah.
Yeah.
Yeah. So you can substitute these in. So I think it's 3 on there.
All right, I can answer 3.
All right.
It's an intermediate
value with you.
I drew a quick graph, which I haven't filled in. Yeah, it's just on the side.
Why didn't she teach us any of this?
Well, because she's like Mark
She was
Fisher.
like, you can learn. Here you go.
This
Yeah,
is
you can
AP.
learn.
Mark
Okay.
Fisher was
To
To be
very.
fair, this is
I
how
just learned all
college
this.
classes are taught. Like, you just
Gotcha.
get
Well,
them
you
to
just
say
find
it.
Jake. You just find wherever Jacob Jordan is, and you get him to host an
Yeah.
open whiteboard.
I'm keeping contact with Jacob on Discord.
Unless we go to
That's-
Florida together, then he'll just be right
If
there.
f is continuous
At my
on 2 to
disposal.
6
At my
with
disposal.
f of 2 equal 20 and f of 6 equal 10, then the intermediate value theorem, ooh, spicy, says which of the following is true. So you're gonna, this is to help you visualize, but it's gonna be within these bounds. So 20 and
What
10
is
are
the
the bounds.
intermediate value theorem?
The intermediate
It's the-
value theorem sounds crazy. It sounds complicated. But what it just means is that if something is continuous, it has to go between these 2 points during this interval.
So like it says there's going to be if there's a value, if f of x like, oh my god, I'm doing so bad. There's 20 and 10 is the higher and lower bound from 2 to 6. Right? There's going to be a value of x in between where f of x is equal to like 17 because that's in
Yeah.
between those two. Like if you look at my graph,
There
There's some
must be
values
a solution for
Right, because
every
it has to
value.
get from one to the other, right?
It has to get
yeah,
from
and
one to the other.
it's a function, so it's not gonna fail the vertical line test.
it could be
25
like
is not
this.
within our 25 is over here. It's not within our
No,
range.
but it says 25 does not have a solution, and it's possible for 25
It's
to have
possible,
a
right?
solution. As you see
Yeah.
through this beautiful red
Oh,
function.
right.
What about 0?
So
Can
that's
0 have a
correct.
solution? Can it go down
Well,
to 0?
but it doesn't have to have a solution. Well, this
Which of the
implies
following
is
is
that it has
true?
to have a solution. Yes, it's possible that you could have something like this.
Or is
However,
it 2 only?
it's 1 and 2.
Yeah.
Wait, what?
Oh, yeah. Wait.
Because
What?
25 does not have a solution on 2 to 6, but it can have a solution.
Yeah, it can. Right?
What?
Wait.
No, but
Wait,
which
so
of the following is
it's-
true?
It's not true that it doesn't
It's
have
wrong.
a solution.
Yeah, it does have a solution. So this is incorrect. So it's not
3,
1
It's 2 only.
It's 2 only.
because it can have a solution.
Oh, it's
Right? That's how that works, right?
Wait.
Yeah,
So
English
which of the
just left
following?
that.
Which of the following is true? 25
Oh, okay.
necessarily does not have a solution.
Well, but
Okay.
it can have a solution, so
It
that means
can.
it's false.
It can have a solution.
And 0, it's saying
So-
has a solution, but not necessarily.
0, it can have a solution.
But not
And
necessarily.
17,
So that's why
it
it's
can
wrong.
have a solution.
Why is it E?
Yeah, no, it has to be. Wait, what?
No, because we're using this thingy.
Dude, it
I'm not
doesn't
using
say
your
this.
stupid things.
It doesn't
I'm
say
just
this.
I'm just using this one.
I feel like
2.
it's 2 only. Yeah, 2 only.
You have to because it specifies intermediate value theorem, so you have to use what I'm talking.
And by the
You
way, I
confused.
got this answer the first time I did it, so this shows that I'm
You
only getting
confused me
smart.
the second time we did it.
Yeah,
I
it
was like,
shows,
what?
it shows that I'm only getting smarter.
Clearly,
I get it.
Alright,
the
let
brain
me,
is
let
enlarged.
me redeem myself for answering this one because I know this one. But I know this one by
Okay.
heart, okay? If
Alright,
x
you got
is
this.
continuous for all x, the maximum number of horizontal asymptotes that the graph of f can have is. Can we take some guesses from someone who's not me, Tom, or Aaron?
C.
2.
Oh, let's go, Sam.
Wait, we're thinking on the same wave.
we're on the same.
Whoa, that's what
airplane
we
Yeah,
right
you're
thought
right.
too. After
You're
Is
right.
it actually? We're
Like,
pro guessers.
Yeah,
I thought that from the very beginning.
I just guessed.
I thought it was
Fully.
1, but
I
It can
just
have
didn't think.
asymptotes. It can have both a negative and a positive. As it approaches
Wait,
both negative
explain
and
this
positive.
problem because I
infinity.
just said a random number.
I am explaining
he's
it.
doing it right now.
Jacob, explain it.
Shut up. Can you server mute him?
It can have a horizontal asymptote as it approaches either positive or negative infinity. So there are 2 possible horizontal asymptotes. Since a horizontal asymptote necessarily stretches out all the way to infinity, and there are only 2 versions of infinity on this dimensional graph, the positive and negative infinity that you can approach in the horizontal direction, there are only 2 solutions.
Do you know what algebraically that this function looks like? Or it doesn't really matter. I was just
It
curious.
doesn't matter. Can we please keep
This
going?
Okay.
is
Wait, no.
this
I
is,
don't know what you're saying.
No,
What is-
Tom Yao is saying nothing of importance.
No, not Tom. I don't know what this. What are you doing? Like, what is this graph?
It's a graph
So
with
you
2
see how
horizontal
it
asymptotes.
approaches a different value as it reaches negative infinity as it reaches positive infinity.
Oh, for all of x.
X to infinity.
Okay.
Yeah.
Oh,
By the way, it has to be continuous. Yeah, see, that's why you connect it. Okay, I see.
Yeah. You see how it's all connected.
Yep.
Alright. Bring in.
What if it's just
The
like a straight
FRQ.
horizontal line?
Then it only has one.
We should
horizontal
also
asymptote.
look at 8 real quick just to make
Then
sure
could it
people
be
know
B?
that you can cross the
But
horizontal.
it's the maximum number. It doesn't matter that it's possible for a graph to have one horizontal asymptote.
Yeah, you want the
You
biggest
can
value.
also have you can also have
Oh,
0
alright.
because you can have x equals y.
Okay. Alright, I got it.
Alright.
Real quick, This is-
Ooh.
this
Get
is
us started on this one. Guess this is where I really showed
He
my
got me.
strength by getting.
Jacob
by
got me
getting it.
here.
Alright, you want to explain it this time to make sure you got it?
Yeah.
Is this format like super common for questions? The like
Yeah.
when you're
I hate
trying-
it.
I'm guessing
it's
this is like
common
AP
in
level.
Here. This seems like a common thing for AP to do because it requires you to think about subjects
This
that
is
you
also
already
common
know
on
in
the
a new
SAT
way.
as well, so I'm assuming College Board.
I have seen barely questions
Okay,
like
do
this
you
on
want
the SAT,
me?
Tom.
Do you want me to explain it, Tom?
What kind of
I don't
SAT
mind
are you
explaining
taking?
it.
I want E on.
I'll
this
go
question
ahead.
personally.
So
Okay.
for one, we have to be a little careful here because a horizontal asymptote, by definition, infinity, it would approach the value of the horizontal asymptote. So that means the line, they actually can cross the horizontal asymptote. So this is false.
Yeah,
This
so
is, it
the
never meets the
simplest
line.
example I have of this is sine of x over x, which it gets the amplitude gets smaller as it approaches its horizontal asymptote, which is x equals 0. But it actually crosses over this asymptote an infinite number of times. So it is certainly possible for it to meet the line.
Look at those crossing overs.
Yeah, that's crazy.
2 is the definition of a horizontal asymptote. As x increases to infinity, it will eventually approach this value.
Yeah,
this is
so
correct.
That's good. That's good.
F of x is an increasing function. That is not have to be true. You can get something like this, right? Where it's wait. No. You can get something like this where it's decreasing and it's reaching this value.
Yeah, and f of 1 has to be 0. It could still be like, it could be something like this.
Yeah, so it doesn't necessarily have to be an increasing function.
Yeah, so this means...
That means it's 2 only.
2 only. And then once again, 2 only. Alright, you want to bring in the FRQ.
Explain this again. I don't know what you guys just did.
What?
They just went over definitions of.
I was trying as hard as I could to pay attention.
Which
I don't know
part?
What they just did.
Which
the
part?
whole the problem.
The whole thing?
It's just limits of. It's just the
Dude.
definition of asymptotes and limits.
Wait, I wasn't here for a sec. Why is 3 not true?
Because,
what?
Wait, don't erase the common example. Look, you can
Oh, never
make...
mind. I see. Never mind. Scratch that, man.
Okay.
Wait, does increasing mean going upwards or going left?
Increasing means that it increases over time. Like, these are both increasing functions.
Alright.
Okay. Savik, in the interest of brevity of the video, I'm gonna move on, but we can go back to this eventually if you want.
Alright. We haven't done these yet, so this is our first time with the calculator ones.
Oh, that's true. We stopped to watch chess drama.
So we're gonna be doing. Wait, don't tell them. We're gonna be doing this real time with you guys.
Exciting.
All right.
I'm gonna be
I
doing
did all the first 4
pencil.
questions real time, by the way, because I didn't do this before. Let f of x be a function defined for all x with -5 less than or equal to f of x less than or equal to 10. Another squeeze, you see. Also, the limit of as x approaches 0, the limit of f of x does not exist, but f of 0 equals 3. So f of x is constrained between -5 and 10. So we'll make an axis like this. And as f approaches 0, we have a point of 3.
Alright, I'm gonna work this out on the thing. Don't look at my work because I don't think it's right.
So let g of x be f of x times x. Show that g is continuous at x equals 0.
Oh my god, I just moved everything.
What are you doing?
Sorry.
Okay. So this function, we know that x at 0, this function is going to be 0, so we know g of 0 equals 0. And then, here, I actually have to solve the problem rather than explaining it before.
G of 0 is 0? It is 0. Let's go.
Yeah.
I kind of got like something that would, I don't know if it proves it, but it's an example of it working.
So yeah, like we see here, we have a removable asymptote at 0. But I think this is realistic. There's a removable asymptote at 0, but it still equals 3. Right, the function value.
Wait, it
is
should be
3.
plus. There we go. Nailed it. Plus.
And let's see.
Okay.
So x.
I have the algebraic work if you'd like to see it, Jacob.
Wait, where's the algebraic work? Oh,
Okay.
I have it shared screen. You know what? You want to
Okay.
explain this question? Because you've already started
So-
doing the work on it.
Yeah. Since it tells you that there is like a removable asymptote since the limit doesn't exist, but find at that value, that means there's probably a removable discontinuity there. So I'm gonna put x plus 3 in there so that when x equals 0, it's 3. Wait. This does not work.
Yeah. So the issue with this is that in this case, the function would be undefined, but the limit would exist.
I got it backwards. This is amazing.
So actually, there would have to be like some sort of jump or infinite discontinuity here. Oh, this is a confusing question.
I'm already so confused. Wait,
If it helps, I don't understand it either.
I've never
Don't worry.
seen. Wait, hold on.
I don't think any.
I don't know what's happening either.
What? Why is it x times
Tom,
n of
what if the
one-
function?
Oh, it's a piecewise. Oh my
Yeah.
god,
Wait, how is A
I'm-
the right equation? I'm confused.
it's wrong. It's wrong. It's a piecewise.
Where are you
Okay.
getting these equations?
Oh, that's a level. Right
It's
there.
a jump. I'm just making them up. Like I'm just seeing what works and just plugging it in.
Wait, Quinn, what are you confused about? Like,
Oh,
can you not understand that the graph can go up and then down?
hang on, she's server muted.
Wait, what?
She's not in
She's
the
still
class,
confused on the
but
2-6 one.
I
'Cause
did
she
that
doesn't
in
understand that the graph can go up
with-
and then down.
You're doing piecewise function.
Because we know that the limit of as x approaches 0 of f of x does not exist, but f of 0 equals 3. If the limit does not exist, that mean that it approaches different values from both the negative and
Damn.
positive side.
When you're unmuted now.
Wow, thank you.
That's a big win for the community right here. Hopefully, no one makes it to the end of the video.
No,
because
I
it's
was just
injustice.
confused on the question because I don't
No,
know.
It's
just-
like, you know how like a
No,
sine
it's
graph can
really
go up
ended
and then
in-
I'm
down?
so,
No, yeah,
I'm
no,
so
I know.
scared
I
of failing the
get what you're
FRQ
saying. It's
section.
just I
of
wasn't
this
thinking about it like
test.
that, so I was kind of confused.
What is h of x, Tom?
I just put h of x because it could be any function below as long as this part is going to equal 3 when it's there. I guess it can't be h of x because it could be also x plus 3.
Wait,
Just not.
can f of x and h of x be the same equation?
No, this cannot equal x plus 3 because then it'd be
What?
continuous and it would have a limit. There has to be a split.
Then why'd you say it? What?
I'm just trying to indicate that it has to have a function like this and there has to be a jump
Yeah, well, I
like
know
this.
that.